So last time we discussed several patterns. So we said patterns are important to improve the quality of the software architecture. We have discussed several patterns like layers, model view controller, I guess, right? Repository, blackboard, pipes and filters. And they are all beneficial for specific type of applications. The next pattern is the broker pattern. The broker pattern has actually some history. If you look at the history of computer science or software engineering, in the early days we had just like mainframes, just huge computers in which all the software was located on the same machine. And typically we could, if you look at the software in general, we can distinguish between presentation, application, and resource manager. In the mainframes, all these layers are just put on one machine. And you have several clients which are just dumb clients which don't do anything. All the processing is just done here. Later on, the client-server paradigm was introduced together with the with the increase of power of personal computers. Then the presentation logic was moved to the clients. Okay, so we had clients and we had servers. And on the server side, usually we had the application logic, resource manager layer. Okay? But the interface, the presentation layer, was just done here. Okay? What's the advantage of this? Every client could have just its own interface. Okay? We had just separation of concerns there. Together with the client server, actually the notion of API was introduced because every client had to access the server, so they defined the API for servers. In addition to that, concepts like remote procedure call were also introduced with the introduction of client-server paradigm. We say this is a two-tier architecture. It didn't stop here because the clients, so we had multiple servers, and the clients wants to use also the service of these multiple servers. But the integration, so to use these servers, the client has to integrate these two. Okay? But at this time, in the client-server paradigm, there's no common business logic for integration. It's just implemented at the client, and actually, if these systems are just heterogeneous, different, it's really a problem. Okay? So there was no integration logic here. Okay? That's so that's the limitation of the client-server paradigm. It's limited. There are some other limitations, but to address the broker pattern, this is the focus. Well, what's the broker pattern? Actually, broker pattern is somehow addresses also this problem. You have multiple servers, multiple clients. They are all working on different platforms, different programming languages. So we say we are dealing with a distributed, heterogeneous system with independently cooperating components. The problems, the client should be able to access these services provided by the servers through remote, location-transparent service invocations. Location means intransparent, means the clients are unaware of the physical address of the servers. Okay? It's transparent. Okay? If they are unaware, so then they become more. The system becomes more flexible, and it's more easy to integrate, as we'll see later on. The second problem, you need to exchange, add or remove servers at runtime. Okay? How can we do that? A broker is a solution to this problem. So what do? You have a client, you have a server. The actually part of the integration logic is just done by the broker. The clients do not directly access the server, okay? But they access the server through the broker. So they submit their request to the broker. And the broker finds the server, and the server executes the request, goes back to the broker and the client. So the servers register themselves with the broker for this pattern. Clients access functionality of servers by sending a request via the broker, and the broker locates the appropriate server. Okay? So this part, locating the server, is not done by the client anymore. Okay? And that actually eases the integration, because you are unaware of the address of the servers, so you don't put it in the implementation of the client. Okay? That's actually the history, and actually we have seen several implementations, like the Corba, it's like middleware. We call it also middleware. A full broker becomes like, then you get all the distribution logic gets into that middleware. But here in the broker pattern, it's just for the accessing the request, for location transparency. This is the pattern. We have actually 6 components here. 2 key components are the server and client. The server is a system component which implements functionality through interfaces. Okay. You have server, you have some services here. The clients are applications that access the servers, the services of servers. In the client-server paradigm, it was done just directly. But here, the clients call remote services and forwards requests to the broker. It's the client, so there's no direct connection, but it goes through the broker. To call a service here, the client forwards the request to the broker. After operation has executed, clients receive response or exceptions from the broker, not directly from the server. Okay? So everything just goes through the broker. The broker is responsible for transmission of requests from clients to server, but also transmission of responses and exceptions back from server to client. As such, the broker provides an API to clients and servers that include, on the one hand, operations for registering servers, okay, and for invoking server methods, like forward request, forward response. Okay. So the broker just keeps a list of these servers. In order to be accessible, the server should register itself to the broker. In addition, additional services such as name services or marshalling support may be integrated into the broker. Okay? Name service is just every server has some ID, unique ID, and that's kept in the broker. Marshalling, you map the data to some machine-independent format. Okay? And that you submit through the net. Besides of that, we have the client-side proxies. Client-side proxies represent a layer between clients and the broker. Okay, so it's it provides transparency in that remote object appears to the client as a local one. I think we have not discussed the proxies, right? But proxy is just also you don't directly access the broker here, but in a similar sense, the communication goes through the proxy. The proxy hides implementation details from the clients, and very often client-side proxies translate object model specified as part of the broker architecture pattern to the object model of the programming language used to implement the client. Which means this could run on a different platform, different language. This could be a different language, and the client-side proxy takes care of that. So it just translates the request here, which could be from in the language, the ideal of the broker. It maps to, for example, Java, okay, which is done by the client-side proxy. Similar sense, we have server-side proxies, okay, responsible for receiving requests, unpacking incoming messages, unmarshalling the parameters. So it goes to the server-side proxy, and calling the appropriate servers. Further, they are used in addition for marshalling results and exceptions before sending them to the client. The client-side proxy receives the incoming messages from the broker, unmarshals the data, and forwards it to the client. Okay? It's clear? Well, if you have different brokers in the system, then a bridge, so-called bridge, can be introduced, which is here. It has a similar responsibility as a broker. It defines actually the communication between the brokers. Okay? So different brokers might need to communicate independently of different network and operating systems in use, and the bridge actually encapsulates all these system-specific details. So when a request arrives for a server that is maintained by a local broker, the broker passes the request directly to the server. But if you have different networks, and if it appears that the service and the server is not on the local network, but at a different network, which is actually controlled or which has a different broker, then the bridge takes care of that. The service is submitted to that broker. Okay? And so in that sense, we can define the integration. So what's the dynamic behavior here? Initially, so we have a broker, we have server, which starts first. The broker starts, it gets in the initialization phase, the main event loop, and then at some time some server is initialized, and to be accessible, it should register itself to the broker. It says, hey, I am a server, I'm located here, please put me in your repository of servers. This updates, the broker updates the repository, then it provides acknowledgement, and this gets into enters the main loop. So what does this wait for? It waits for request of clients for addressing some servers. But the access will not be directly done, but just through the broker. Clients will not be aware of this. Okay? So broker starts, initialize, then some servers initialize, then they register themselves to the broker. Then if we have a client, the client can send a request to a local server. Client, another application, which wants to use the services of the server, the client application is started. During the program execution, the client invokes a method of a remote server object. So it's not local, but remote, at a remote server. Typically, the request goes to the client proxy, which packages all parameters and other relevant information into a message, okay, which is understood by the broker, the data format, and forwards this message to the local broker. Okay, pack data forward request. Okay. The broker tries to find the server in its repository and then calls the server through the server-side proxy. The server-side proxy unpacks all the parameters and other information, such as the method it is expected to call, and then it executes a server, so run service. The service is executed, then the result is returned back to the server-side proxy, which forwards to the response to the broker, which forwards to the client-side proxy, and eventually it gets at the client. Okay? In this case, the client is not aware of where the server is actually located. Totally location transparent. Okay? What's the advantage here? Well, we can add new servers, but the protocol is just the same. Servers will be accessible, provided that they just register themselves to the broker. Okay? Quite easy, actually. This is interaction of different brokers via a bridge, as I said. Excuse me, broker A. So here they are on different networks. Broker A and broker B are on different networks, but they are connected through bridges. Broker A receives an incoming request. It locates the server responsible for executing the specified service by looking up in the repositories. It appears that the corresponding server is available at another network node. If it's in its own network, the broker can just find the server. And then we get this mechanism. If it's another network node, then it forwards the message to the bridge. The bridge communicates, the bridge on network A communicates with the bridge on network B, and in this bridge forwards the request to the broker on network B, and there the server is found. Okay? So we have some intermediate layers. So as you can see, there's lots of communication here. Okay? There's no direct call to the server. Everything goes through the broker. If we have different network nodes, even we have communication through bridges. Right? There's another variant of the broker pattern which takes this into account. So for performance reasons, you might relax the restriction that clients can only forward requests through the local broker. In this variant, clients can communicate with servers directly, but it's not as in the client-server pattern where you don't have broker at all. But here again, the servers, they register themselves to the broker, but what the broker here does is just so initially, so the first time the client accesses the broker, it finds the server, and after that the broker provides the address to the client. See? After the client knows the address, then you can proceed with direct communication. So not for every request the broker is used. Okay? Client accesses the broker finds the server address. The server address is provided to the client, and after that the client can communicate directly with the server. Okay? But initially the client doesn't know the physical address of the server. In this case, in such systems, the proxies take over the broker's responsibility for handling most of the communication activities. Okay? Again, so even if the server gets the address of the or the client gets the address of the server, the communication is done by the proxies. So still the client can be unaware of it. So then location transparency is defined by the proxies. Okay. Questions about this so far? Another variant is the trader system. Usually a client request is forwarded to exactly one uniquely identified server. But often services and not servers are important. You don't care about, you just want to execute some service. And you don't actually care, the client doesn't care about which server executes it. So in that case, you can use the broker pattern variant, which is so-called trader system. In a trader system, the broker must know which servers can provide the service and forward the request to an appropriate server. As such, the client-side proxies use service identifier instead of server identifiers to access server functionality. And the same request might be forwarded to more than one server implementing the same service. Okay? So then we get another sophistication. Not a decoupling of client and servers through the broker, but separation of services. Okay? And that brings us exactly to what we say the service-oriented architecture. Okay? It's just the follow-up of the broker pattern of the middleware technology. What do we have? I will not elaborate on this in detail. Just one slide here. Here we have again, we have three components. The service requester, we could say it's a kind of client. The service provider, kind of server. Service registry, repository where all the services and servers are located. The service requester is potential user of a service provider, entity that implements the service and offers to carry it out on behalf of the requester. Service registry, a place where available services are listed, not the servers, and which allows providers to advertise or to register their services and the requesters to query for service. See? So once you understand the broker pattern, it's also more easy to understand this whole web service idea. Okay? So we had mainframes, client server, then we had broker, lots of middleware, and the next evolution actually web services. This is the next separation of concern. What are the benefits of this broker pattern? Location transparency. A broker is responsible for locating servers, not the client. The client doesn't know where it's located. Even the client doesn't know whether it's on a very different network. Okay, it's all done by brokers and possibly through bridges. And similarly, servers do not care where clients are located. Okay? You don't have tight coupling between these clients and servers. Totally loosely coupling. Because of this loose coupling, it's more easier to integrate all these servers and the clients. Okay? Enterprise application integration, which is also called. Changeability and extensibility of components. If server implementations change without affecting the interface, that interface clients should not be affected. Without affecting interfaces, clients should not be affected. So we could say server has some API, okay, some interface. The clients actually know that, not the clients, the broker can access that interface. Provided that you don't change that interface, you can just change the implementation. Portability enhancement. The broker system hides operating system and network system details from clients and servers by using indirection layers such as APIs, proxies, and bridges. Okay. What's the concern here? The clients, so we have a heterogeneous distributed network, different components working on different operating systems, different languages. Exactly all these concerns are addressed by the broker pattern. Second, when porting is required, porting to a different platform, different language, there was sufficient in most cases to port the broker component and its API to a new platform and to recompile the clients and servers. Okay. Reuse of services. When building new applications, brokers enable application functionality to reuse existing services. So the clients should just enter the network. They just should know the broker. Once they know the broker, they can access all the servers which are in the registry, in the repository of the broker. Reuse. Okay? You don't need to implement, the client doesn't need to define these services. Interoperability with other brokers. You have different brokers. They may interoperate if they understand the common protocol for exchanging messages. Interoperability means that you have different components on different heterogeneous platforms, but they can still understand each other. Okay, the data format, the functions, etc., the language. On a local network, it can be done by just accessing the language of the broker. If you have multiple different networks, then the broker should have a common language. Okay? We also say interface definition language, or like we have now the web services, WSDL is also a kind of interface definition language for describing services. Okay? So if everybody knows the same language, then if you are working on different platform or language, you just map that to the common language, then you can interoperate. Okay? Quite powerful pattern actually. There are some drawbacks. It provides some flexibility through introduction of intermediate layers, but as usual, if you introduce new layers, new intermediate layers, so this has some penalty for the performance. So you have restricted efficiency. Applications using a broker implementation are usually slower than applications whose components distribution is static and known. That's almost trivial because if the client knows the servers, then you have a direct access. So you don't need to pass through the broker or bridges or whatever. Okay? Systems that depend directly on a concrete mechanism for inter-process communication also give better performance than the broker architecture, because broker introduce indirection layers. You have lower fault tolerance. You have a broker, is still some centralized. If the server or broker fails during program execution, all the applications that depend on the server or broker are unable to continue successfully. Imagine you have one client, several clients, one broker, multiple servers. If the broker goes down, then of course you get a lower fault tolerance. And we have single point of failure. Testing and debugging is also harder. It's distributed systems, heterogeneous, and all the components are involved. It's a dynamic, it's runtime, it's very hard. What are some examples? Corba was very well known. Microsoft's OLE, World Wide Web, the hypertext browsers such as Netscape act as brokers, and World Wide Web servers play the role of service providers. Question about this? Okay, short summary. Who can give short summary? Why this pattern? Could you use this pattern in your project? And why? So just give a concrete example. Yes?
Yes, we can. We have multiple servers in our, maybe multiple servers in our system.
What kind of servers? For bank application you had, right? Yes.
So, in order to access all the servers from client side, we should have an intermediate level. So, broker pattern.
Okay.
Good enough.
In many distributed applications which are working on different heterogeneous platforms, broker pattern is suitable actually. Okay, now it's the time to break and we will continue in 10 minutes.